project is the Trust and AI-enabled decision support system, and this project is focusing on evaluating a tool called the multi-source AI scorecard table and the extent to which it can be used to assess the trustworthiness of AI-enabled decision support systems. MAST is intended to be used as a way to quickly evaluate these AI-enabled systems. It's essentially a checklist that goes through 9 different criteria that evaluate the outputs of intelligence analyst reports. And so the question is whether or not these criteria could also apply to AI-enabled decision support systems in security type of settings. Right now, it is in some ways futuristic because I think the types of AI-enabled systems that MAST is intended to evaluate are currently still in research and development. But the idea is that in the future, if you have these really advanced capabilities that can synthesize a large amount of data for an end user, which might be an intelligence analyst, can we evaluate the outputs of those systems in a way that's similar to how we evaluate the outputs of human analysts?
So my role in this project is sort of like an intermediary between the human factors people and the computer science folks. So this team is very interdisciplinary. We have people who are specializing in visual analytics. We have pure data science folks, we have pure computer science folks, and then of course we have the human factors, human systems engineering members of our team as well. And so I do understand I can speak the language and the jargon from the more technical side and then the more human side of the research. And so my goal is to translate the language of each group to each other, and also to make sure that the technology that we're developing to test for this project has all the features that we need so that we can meet our project goals. So what we're hoping for at the end of this project is that we can see strong associations between what we see to be trust perceptions or perceptions of a person's trust in a specific technology, and how they rate the features that are listed in the MAST questionnaire.
I care about trust in technology because you don't want operators to over-trust technology, and you also don't want them to under-trust technology. So getting a good understanding of whether or not people trust the technology can be very useful. There's also this notion of calibrated trust, meaning that people's expectations about technology and its performance, purpose, and process match up with that technology's actual performance, purpose, and process. It's important to study trust because you want to understand or be able to predict how people might use it. And so understanding and being able to assess to what extent people trust that technology and the way that it works will be important for any future type of technology design, implementation, or operation in security settings.
Right now, this topic of trust in automation or trust in artificial intelligence more specifically is a very hot and very hotly debated topic. That's what I'm getting from the collaborations that I have with the human systems folks. And the way that I understand it is that we somehow need to develop or maybe redesign some of the trust measures that have been used in the past. So it's different when you're trusting people, right? So a person's trust in another person, that's going to have, certain elements that are probably going to be different when you're looking at a human trusting counterpart, artificial intelligence agent. And so this project is dedicated to the second scenario where we're trying to see what are, the constructs of this trust perceptions when the directionality is that a human is trusting or is expected to work with an AI agent.
We brought our 2 test beds to the San Diego airport and had transportation security officers interact with our test beds. So essentially they were doing a face matching task with different implementations of the particular interface. One that would meet a mass high rating and another that would meet a mass low rating. We had them interact with those systems and then surveyed them with a couple of trust questionnaires. And what we're going to do is see whether or not those responses to the trust questionnaires align with their mass ratings. And so this is one way that we're trying to validate the mass tool, but we'll be doing it with actual transportation security officers and not just with a general public type of population.
I think that the bigger picture of things is if you have this kind of validated type of survey or type of questionnaire, then it's easy to do future studies on anything that might come up in the future as far as black box artificial intelligence technologies. And right now we just don't have those standards. And the purpose of the mass survey really is to prior to deploying an AI technology, you're actually asking the boots on the ground, the people who are actually going to use it, well, what do you think about this artificial intelligence technology if we deploy it? What's your perception about its reliability, its relevance to your objectives?
DOE has been central in supporting the next generation of researchers for doing important research that is relevant to the Department of Homeland Security. Our student team is multidisciplinary, and that sort of reflects in the different investigators that are involved in this project. So we have undergraduate and graduate students in statistics, data science, human systems engineering, and computer science, all collaborating to help us be able to realize the goals of this project.
I am in human systems. So basically, I do a lot of the design and development of the systems. Then I hand those designs off to the actual computer engineers and they create those systems. So I write a lot of system documentation. I do a lot of wireframes and visual design aspects. And then I work together very closely with the actual software, I guess we would call them software developers, to create the systems. I think one big thing was that I gained is learning how to work on a cross-functional team, sort of in this tech realm, learning how to communicate with our expert computer scientists, learning their vocabulary, learning how they process things. I had to do actually a lot of background reading and updating my own knowledge to be able to work with them. So that's been really valuable. And of course, that's something I can take to any job.
My role is actually to design a study interface and interactions. I am also involved in the design of data collection procedures. It is my job to collect and analyze data in order to publish papers. Being in the airport as a kind of researcher was really surprising and it was really a good experience to me. So, always when I go to airport, I'm a passenger. I have to go through the line. It is usually very stressful procedure, but being there as a kind of researcher, being on their team, it was very fun, and it really changed my mindset about TSA.
My role in this project was really to look at how we design these systems with a human factors perspective. And specifically, I designed face-wise and carried that over from a previous study that we did and looked at how these decision-making criteria that we're evaluating, how do we use that to evaluate, or how do we use the decision-making criteria that we were studying in this project to design systems that will be trusted by people who will be using them in the field, rather than just being trustworthy from a researcher or a designer's perspective. part of that is also evaluating these systems by asking people in the field directly to evaluate them. And so far, these two have made me a much better researcher than I was at the very start of this project.
Purpose. My first purpose is just like, Dr. Messino, can you give me some data to analyze and do some coding and use the statistical software to analyze the data and then just draw a conclusion. But she advised me to actually get into the process of how do we design the experiment. It's very important to know how to design a good experiment and then how to collect data, and then we get the data and then we can analyze the data, because she said that analyze the data is the easier things in the whole process. So I need to know everything. I need to know the whole process from the beginning. So I actually very grateful that she instructed me and put me into this project. So I learned a lot. I have learned a lot.
I think allows us to come up with systems and questions that I think we would never arrive at just by ourselves or just by sticking to our comfort zones or immediate research bubbles. So being involved in this project has made me really appreciate the value of interdisciplinary research and how it is the path forward.
And I think just having so many people from so many diverse backgrounds coming together to try and solve this really hard problem has been one of the most rewarding experiences of this project.
There have been a lot of effort to automate certain processes within the Homeland Security enterprise, an example of which is the installation of face verification system in the security checkpoints at the airports. And so as we see more and more of these black box, artificial intelligence type of technologies, there is that pressing need to understand how people interact with it and how we can improve the work process and the technology itself in such a way that they will feel comfortable in using the technology to their advantage, but at the same time remaining engaged in their work.
I think if we can really validate the MATS criteria and we can really hone it down to a good set of criteria for designing trustworthy AI systems, it could really revolutionize the design of these decision support systems. Mostly because they're considered black box or opaque. They have no idea, behind this screen what's going on. So if we can really work past that, we could really bridge the relationship between the AI and the humans to really create the best outcomes.
So in the long term, I think that our research will really inform the development of standards when it comes to evaluating the trustworthiness of AI-enabled systems.